Wear a bow tie. There you go. I used to have a gold sequin. So nice that we got people helping you with your fashion sense.
But really, like, dress how we supposed to. But you can do what you want.
I have gray pants.
That works. Gray pants work. All right. So yesterday you watched Ed Puzzle by Mr. Anderson on balancing equations. Hopefully that was like way easy, but maybe not. And it's okay if it wasn't, but hopefully it helped you. A lot of the equations that he went over were some that we've already done. So yeah, we're going to take a peek at the simulation and do some practice with the little first game segment. And then we got 2 reactions to do today. Super fun. We get to light our burners and burn some magnesium. Life is good in the neighborhood. So, excuse me. And we'll go over the types of reactions and all that kind of rot as well. So let's get this show on the road. Did anybody watch the video of the old guy that I posted last night? He is so great. Yeah. Did you watch it? Oh my gosh. Oh my gosh. I'm going to make you guys watch it then at the end of class because it was so inspiring. Anyhow, pretty cool. He's 96 years old. He used to be a dancer up until 92. He just has a great outlook on life. I hope I'm above ground at 96 if I'm as lucid as he is. So that's not what I wanted right now. Sorry. This one, that was what you watched. That's very distracting for me. I'm very ADD. Please don't do that. Okay, thank you. And it was right here. Where did it go? There it is. All right. So that simulation hopefully was useful. And so you did the introduction part. We're going to try the little game part right now. So you can do this on your own if you want to too, but we'll just do the ones that they present because they come in different order and there's different ones. So actually I haven't seen this one yet today. So that's interesting. Again, because of the nature of the beast, you have to put in the ones. Normally we don't put in the ones. And just once you've written the formula, we're good to go. So we're going to ask Amani, what do you think about this one? How many phosphorus on the left? Good. How many on the right? So that's golden. How about chlorines on the left? Gwen. Yeah. Good. And how many chlorines are on the right? Colin.
5.
Perfect. Guess what? Once we get the formulas written, we're all good on this one. It's all done. So 5 chlorines go with this phosphorus. That's a highly unusual. Remember, phosphorus isn't the same family as nitrogen. Sometimes it does the bipyramid thing. And this is one of those times. And then normally it would just have 3 and a lone pair on the phosphorus like nitrogen. But this should be good, I think. There we go. Next up is carbon dioxide. And on the left, carbon monoxide and oxygen on the right. So let's start out with what type of reaction this is. Jack. Actually, both of these were the same type of reaction. Jack Conte, sorry. 1 thing to start with, 2 or more things at the end.
Single.
Nope. How about Aiden? What do you think? 1 thing to start with, multiple things at the end. Kais? It is a decomposition. It's falling apart. Good job. All right. So, Lauren, we have a problem here. Houston, we have a problem. So what can we do to fix it?
We have to make it so that there's more oxygen
Correct. And we need to have even oxygens. So where are we going to start?
By adding subscript.
Nope. These are written correctly. We don't get to add subscripts. Don't add subscripts. Coefficients. So I'm going to put a coefficient here. Now we've got 2 carbons, 2 oxygens, plus 2 oxygens. So we have I can talk, 2 carbons and 4 oxygens altogether. What do I need to do to fix it? Perfect. And that should be good. This one is C2H6 on the left. These are all decomposition so far. And C2H4 and H2 on the right. Jackbird whistle. What do we need to do with this? Anything? No, I don't think so. I think it's all good. Okay, we got 6 hydrogens on both sides and 2 carbons on both sides. We're golden. So carbon and oxygen make carbon dioxide. Michael, what kind of reaction is this? Nope, we're not replacing anything. What are we doing, Bethany? Nope. That's possible, but there's no water there. What are we doing? Taylor. Two things becoming one thing. It is combination, synthesis, combination. So decomposition, you would think it would be composition. Galileo, what are we going to do to fix this? Anything? Nope. They're all done. Boop. All right. It's not here. This is really unusual. They should have had an 8 here. Sulfur runs around in groups of 8. And some of these you might see that like phosphorus has 4. Most of the things that we emphasize and talk about in chemistry, beginning chemistry, are the diatomic elements, but there are others. But we'll just go with how it's written here. Logan, what do I need to do to fix this? Yep. And I think we should be good. Yes. And so again, 2 things making one thing is combination or synthesis. Oops, it's not the right button. I think we have one more. Nope, we did it. Woo! Okay. So just a little practice. We'll keep practicing and reviewing our types of reactions as well. Any questions? Any questions from home? All right. Seeing none. Let us then go to the next item, and that is our lab. And I'm going to pull up the 6th period lab. Sorry. So those of you in the classroom, get out your hard copies if you haven't already. And get out your yellow and purple papers as well. Please. Okay. Alrighty. Recording, I'm presenting, everything's golden. I don't need that anymore. So we've done 5 reactions already, and we went through, I think, all of them in here. I'm trying to remember. Let me just scan. There's that. Oh, no, we need to talk about 4 and 5. Okay, so let's do that real quick. Number 4 was the zinc and the copper chloride solution, the solid zinc metal. So you should have something about this shiny silver metal solid, and then the blue, turquoise, teal, whatever color you want to call it, copper chloride solution. And you should have seen some brown, black, reddish brown, rusty looking stuff come out. And the solution probably got clear or less blue, at least while you were doing this. And that's because the copper was coming out. So on this yellow sheet, there is a whole list of metals, and zinc is up in the top third and copper is down in the bottom third. Well, the zinc's barely in the top third. It's above the half mark. And then copper's down the bottom third. So that means zinc is more reactive than copper. That means the zinc can knock copper out of solution. Okay. And so this is then an element with a compound making a different element with a different compound. So what are we going to call that type of reaction? Caius. One thing is changing places.
Single replacement?
Yep. Okay. And you probably can't tell anything, but you should have some observations. And the cool thing on this, I already got the formula correct for you because zinc's a +2 and chloride is always a -1. Excuse me. Chloride's always a -1. They go together, 1 zinc with 2 chlorides. So it's done. No coefficients needed. Everything's copacetic, both sides of the equation. Questions on reaction number 4. Beautiful. All right. So the next part is sodium chloride that was in the dropper bottles, clear and colorless, it should have been. And then silver nitrate was in the brown dropper bottle. It might have had some little black specks in it because it is photosensitive. But tell me the charges on sodium and chlorine. Colin. They're the same people. Get to the bottom of the barrel here.
Sodium and chlorine.
So you can look on this too. It has all the charges.
Chlorine is -1.
It is. And sodium?
Is +1.
Perfect. So I'm going to write the charges in the formulas, even though you're not supposed to. Okay. That's just for making my point. All right. How about, would you please look up, oops, I already pulled somebody, Jepper. So would you please look for silver and tell me its charge. And Gabby, tell me what the charge is on nitrate.
Silver +1.
It is +1.
Nitrate.
You have to go by the names. What's up? No. Nitrate is NO3 and it has a -1 charge. So it's -1. Sorry. So they don't write the ones. Again, that's extra baggage. If you went to the trouble of writing the plus or minus, you don't need to write the 1, I guess. I don't know. Anyways, these are both compounds that are soluble in water. When you combine them, the positive from one can go with the negative of the other, and the positive from this one can go with the negative of this one. So this is my innies and outies. A little silly way to remember this. What is the official name? Taylor. Two compounds making two different compounds. Mm-hmm. Oak and silver can go with chlorine, sodium can go with nitrate, and that's the possible new combinations. And since they're all ones, it's really nice. Okay, remember, put the positive one first, the negative one second. Okay, now here's the next thing. What happened in that reaction? Gwen. It bubbled? Really?
Oh, wait, sorry.
Number 5.
It turned white.
Turned white and cloudy, right?
Yeah.
Okay, cool. So one of these new compounds is insoluble and forms a precipitate. Okay, so when we put things together and we see cloudiness, okay, that means a solid is forming that doesn't dissolve in water. And so our next task is to figure out which one is the precipitate. So if you look on the table below the activity series, there's some things like the first line says any negative ion plus a positive ion that's an alkali metal. So anything with lithium, sodium, potassium, rubidium, cesium, anything is going to be soluble. That's not a precipitate. Okay, next line. Any negative ion, anything with ammonium is always soluble as well. Nitrate plus any positive ion, doesn't matter what the ion is, anything with nitrate is soluble. So let's think. Sodium's in what family? Oh, you guys are killing me. What family is sodium in, Bethany?
Oh, no, the first one, which is,
Oh, you guys turn to each other and tell each other what it is. It's hurting my feelings. Any guesses? It's an alkali metal. Okay. Sodium, alkali metal. What's the next column called? Alkaline earth metals. You guys need to know that. Okay. So alkali metal and nitrate. What do we know about both of those? Read the first 3 lines again. What do we know about them? No. Both of them are always what? Last column. What's it say? Soluble. Okay, that means they're always going to be staying dissolved in water. I'm up here talking to myself. Okay. Logan, find chlorine on this yellow thing and read what it says about chlorine. Chlorine, Cl minus, or bromide, Br minus, or iodide, I minus. What does it say? Not soluble with silver. Exactly what it says. Yep, not soluble. That means it's going to form a precipitate. Okay, so silver chloride is going to form, but it's going to be the milky white cloudy thing that you saw. Okay, so you can just, ooh, must be nice to get to do that and not have to go see a chiropractor. The other one was the sodium nitrate. You're just rubbing it in, man. Don't do that. Sodium nitrate is aqueous. It's soluble. So it's still there. The sodium ions and the nitrate ions are still there. They're just not, they're just dissolvable. Okay. All right. Questions on that? And since they're all 1 and +1 and -1, we're all done. Okay. Okay. Reaction number 6 is the fun one. We're going to light our burners again. Whoop, whoop. And you'll need hair ties and goggles. You just stay in your seats though right now because I'm going to demonstrate this. The pyro in us always comes out. I'm going to go ahead and get in on this meeting. B6, Y, 7 BP. For BAZ. Beautiful.
why does it say to not let directly after?
All right. So those of you at home will get to watch from my camera. On my phone. Oh, stinker. Come on. Come on. Try that again. I don't know what I hit. Yeah. There we go. Close enough. That's off, that's off, that's off. Nobody's echoing. How about that? All right, so let's review. How do we light burners with a striker? Gas on first. Ooh, and I just remembered. So the other thing you have to do is close off the oxygen. So if you have a regular Bunsen burner, you want to close the collar off. Don't mess with the bottom on the Tyrrell burners. Screw it down maybe a little bit if you want to. Again, remember, you should be able to hear it. And then strike over it. If you're trying to use this striker, it really works better if you do two hands. Is that a good flame? No, it's terrible. What does it need? Oxygen. That's a nice flame. Yes. That's a chemical reaction. Heat and light is a big deal. Okay. So just ask anybody. So I'm going to come around and give each team pieces of magnesium ribbon. And it's not shiny and silver because it's been hanging out in my drawer for years now. I still haven't used it all up. So magnesium is a shiny silver metal. The paste you're going to get has a bunch of magnesium nitride on it, but that's okay. You're going to use your tongs, and you're going to hold it into the hottest part of the flame. It's more entertaining if you do it this way. So the hottest part of the flame is where? Yeah, the top of the lower cone, right? So a couple other things before I forget. When you're lighting with a match, how do you do the match? Strike the match first, then turn on the gas and put it at the side. Don't put it over the top because it often gets blown out that way. So the other thing is, don't stare at this. This will solidify or denature the protein in your vitreous humor. That's the goo that's inside your eyeballs. Same thing that happens if you stare at the sun. Well, it also damages your retina. This is used in flash photography. Back in the old days with little flash cubes, they have a little piece of magnesium in there. It's used in fireworks. If you've seen old reenactments of photography, they have the little stand that makes a bright light. Okay. So stare towards the board. Of course, all of you are going to stare right at it, but I told you not to. Okay. The crazy thing also, so the ash that just came off of that weighs more than the metal weighed before I started. So it's really like, it doesn't make sense if you did this with a piece of wood. Obviously the wood would weigh less afterwards. The weird thing is the metal weighs more. This ashy stuff that's on my counter, you're going to make sure and clean up from your own lab stations when you're done with a little piece of damp paper towel, and then wash your hands with soap and water. All right, so let's get those reactions done quickly as you can. Goggles, closed-toed shoes, hair ties are up here if you need one. Okay, those of you at home, I have to go be in the back of the room with the fire. So if you have a question, ask me now. Hopefully you saw what I did. If not, you'll have to rewatch the video.